go. Let me post some things. All right, cool. So today I'm going to talk about how to write your own Rust C driver. So that you can do cool things with compiler internals. Let me open up some windows. I think this was the one. Oh no, I was using this other one. There we go. One of these. Oh, it's already open to the right file. That would explain why it's not doing anything great. Okay, cool. All right, so last time we got all this code running. Except for the fact that it doesn't actually compile, so it has all these things. I'm going to comment out almost all this code, because it's not stuff that I actually care about. I think if I just say Rust C driver main, it will do the thing that I want. Okay. Great. Cool. So now, this program here is actually pretending to be the Rust compiler, and it's printing all these things here. Okay, so first of all, I want to fix this little red squiggly here. We talked a bit last time about how there's two places that the compiler loads different extern crates from. One is from Cargo's target directory, which is over here and has all of this stuff. And the other one is from something called the sysroot, which is over here, and it's managed by Rust up. And this is where Rust C driver lives. Okay, so because Rust C driver is in the sysroot, Cargo doesn't know about it, and also Rust Analyzer doesn't know about it by default, but there is a magic option that you can hit that turns it on. And if we find it, that's not it, hold on. I'm positive it is here, but it may not be documented. That would be really unfortunate if it weren't undocumented, and I'd be kind of annoyed. Okay. I'm going to see if I can find any reference to it at all. Well, they did something. That's not it. Maybe the other thing I saw with Rust C was it. There's something here. Ooh. Here we go. Here we go. This was the thing that I wanted, I just didn't read. Okay, this is what happens when I type too fast. Let me close some windows. Okay, so if I go to cargo.toml here, and I set some metadata for Rust C driver, then suddenly, I may have to reload the workspace. Reload workspace, try that. That did not help. Okay, there's another thing in this user manual. It said, set to discover to try to automatically find it. Let's see if that helps. I think this has to be set in the workspace settings. VS Code has all these like weird, different places that you can edit this. Here we go. This is what I want. This is what I want. And now I think this will work. Okay, let's try that again. Cool. Yes? No? Maybe? Oh, okay, cool. So you can see down here that after that change, it had a bunch of things that flashed up. And one of the things that flashed up was that it said Rust C driver in the things that it was loading. And now if we look here, we actually get go to definition now. Excellent. Okay, this is what I wanted. Cool. Good, good, good. Let me make this bigger. So interesting thing here, there's a comment at the top here that says this crate is intentionally empty and in report we export a Rust C driver info. So when you have this, so okay, let me back up. So the way Rust's compilation model works is you have a whole bunch of crates, and if we look at the list of crates in the rest-lang repository. I'm going to limit this a bit. Okay. If we look at the list of crates in the Rest repository, there is the binary, which is called restc main. There's all these things, which I'm going to ignore for now, and then there's restc driver and restc driver impl. Now, an interesting thing about restc driver, no, I didn't want that to open a new window. An interesting thing about restc driver is that it is it is a dynamic library, and what that means is that when we put it in, when we compile it, it's not actually creating a metadata file like all these other crates are. It is actually creating a shared object file, and that's the thing that I keep looking at when I look at this directory. Okay, this .so file here, .shared object, is generated because we tell Cargo that it's a dynamic library. Right. So why does that matter? How does that have relevance to the comment? Well, the answer is because to create that shared object file, the compiler has to actually take all these functions that we've re-exported from restc driver impl, all these things, and it has to compile them into object code that the OS knows how to execute. And that takes a non-zero amount of time. And so by putting this shared object file in its own crate that's completely empty except for re-exports, that means that when someone makes a change to the compiler, so say I go over here and I modify, I don't know what's something here, the metadata. Must see metadata. Okay, say I add a comment and I rebuild, then that means that only the crates, oh, well, this is rebuilding the whole thing, but, let me change some things. I will explain what's going on there in a second, but I don't want to right now. Cool. That's going to take a bit. And so it means that when we change this crate here, when we change some crate that restc driver depends on, we only have to recompile the parts of the compiler that are relevant. And so Cargo has something called pipelining, which says that it can build the metadata and the actual crate in parallel. So, okay. This will be more clear if I do an example. Let me find an example. Okay, so I have this custom driver here, and I'm going to take this tiny little crate, which has just a simple lib.rs and some dependencies. Okay, and if I run cargo build -v, and also make sure that it's not cached. Yay. Make sure that it's not cached. Okay, so we see all these things that it prints. Where was I going with this? Oh, yes, okay, and in this final step, okay, so notice how in all these previous steps, it passes this emit flag here. This says emit equals dep info, metadata, and link. Link? Why is it that early? What? I'm confused. I would expect that only to be passed for the last crate, because that's the one where it actually emits an object file. The other ones... Oh, this is a library and not a main function. That's what happened. Okay, so this lib.rs here tells Cargo that this is a library, and if we move it to main.rs, then... Then, suddenly... Is that what it wants? Stop. Oh, I keep closing. Okay. I know I'm switching between 6 things at once, but this will all be clear in a second. Okay, good. Okay, so now that we've renamed it from lib.rs to main.rs, Cargo thinks that it is a binary instead of a library. Now notice that this has changed the crate type that it passes to restc. We do not see this before. Before it said it was a library, now it says it's a binary. And that's because Cargo does this by convention, by the name of the file. Rustc does not have a convention. Rustc goes entirely by this crate type flag. Okay. I think what's going on is that when we pass emit equals step info link, Cargo is just not worrying about whether it's a library or a binary, and so when it passes link for a library, the compiler just ignores that and generates the metadata instead. But when we do it for the binary, and we look at this target directory, suddenly, well, if I get it to compile, like that, suddenly we have this example binary here. And it's named example because the project is named example. So Cargo does lots of things by convention. One of the conventions is that the binary that it generates will by default be the same as the name of the project. Okay. Right, yes, okay. So the reason that I mention this is because Rustc does something different for binaries than it does for executables. I'm going to touch this file so that Cargo doesn't cache it. And now I'm going to do a special command that says I want to run Rustc on exactly one package, and I want it to have these arguments on that package. Print equals link args. Okay, and this printed a whole bunch of crap. This is what the compiler is passing to the linker. Somewhere in here, where is it? Where is it? Come on. Aha. So it is calling a C compiler as the linker, and it is only doing it for this final step. So if I remove the target directory, it will still only ever call the linker once. Let me do this for all packages now instead of just the last package, because I want to show that it only shows up once. Okay, and so you can see that it shows up. Let me make the search a little better so we only see the relevant things. Okay, it shows it when compiling example, and it shows it when compiling build scripts. Let me, how can I tell that this is a build script? I mean, one way is you can just run cargo tree I, which says show me the things that depend on this. I want to find the crate. Okay, tracing attributes. Here we go. Okay, so if I run cargo tree I tracing attributes with the fixed syntax. I need to fix that bug. Okay. Okay. Proc macros and build scripts are the things that get linkers emitted. Okay. So it is running the linker for this final binary, and it's running the linker for the proc macro dependencies, but it did not run the linker for tracing itself. If we look for where it compiled tracing, which is over somewhere. Oh, it'll be crate name tracing because it doesn't actually pass the version number. That's right. Okay. Yeah, so if we look at where compiled tracing, it does not actually run the linker for that crate. It only runs the linker for the final binary and for build scripts. And the linker takes some amount of time to run, and on large projects, that amount of time can be non-trivial. And so over here in Rustc driver, if we separate it out, if we have it in a separate crate, then we can actually very easily not just time the amount that it takes, but we can also get better incremental compilations. It takes less time to rebuild because this final crate only has to rerun the linker, and we can start doing that before the Rustc driver crate, the Rustc driver impl crate has finished. Okay, right, yes, I was going to talk about pipelining. So the reason this works is because of pipelining. So I'm going to run cargo build -timings. This is a command that generates an HTML file. No, I want to open that in Firefox, my God. There we go. This is a file that shows all the things that Cargo is doing. Let me zoom in on this a bit. Okay, so I have this example crate here. It tells us some interesting things. It tells us the profile. So this is either dev or release. It shows us the total time that it took, and it shows the number of jobs that it had running at once. So you can see here, it's not actually making very good use of the parallelism. I have 16 CPUs on this computer, and it's only using 6 of them. But that's because I only have 15 total. So like there's kind of an inherent limit to how smart Cargo can be about this because of the way the dependency tree works. Okay, so if we look at this, why is this? What is this scale? Okay. This is so. Here we go. Okay, and you can see when I hover, it shows what the dependencies in the graph is. So the last dependency, the thing it's actually finally building, is this example binary. It can't compile this example binary until it compiles tracing, and it has to compile all the things before that first. Okay, and so notice how this syn crate here, I'm picking on syn because it takes the longest, has 2 colors. It has this blue color and it has this purple color, and they are different sizes. And that has meaning. The difference between those, if I could, I don't know why it doesn't have a legend for this, but the difference between those is the blue is metadata and the purple is code gen. Cargo can, for most crate types, start compiling as soon as it has metadata, but for the final binary, it cannot start the linker until it's finished doing code gen. Right. Yes. Good. Okay. Let me pull up the docs here. Yeah. Okay. So this is some documentation on timings. Yes. Okay. And so when rustc driver is separated out into its own crate like this, that lets us take better advantage of pipelining, because the compiler can start building rustc driver impl earlier before all the other crates have finished code gen. It only has to wait for them to finish building metadata. And we can actually see in this target directory the metadata that Cargo is generating. If you look at this deps folder, we have all these rlib and rmeta files. The ones that end with rmeta are metadata files. The ones that end with rlib are object files. And they're in their own like special format that only the Rust compiler understands. And when I say own special format only the Rust compiler understands, I mean a zip file. It's a zip file. I think it's AR is the command. This is like all the like Unix toolchain files are really weird. They're really weird. They were made like 50 years ago and haven't changed their interface since. But it does know how to read this file. Okay, great. And this is just like a normal file that a normal Unix toolchain is able to read that happens to have a special extension because we don't want people messing with it because we don't want to stabilize this format. Okay. Right, yes, good. Okay, so that was pipelining. That was the reason that rustc driver was in a separate crate than rustc driver impl. Okay, that was a very long digression and not related to the thing I actually want to do, which is to talk about how to use rustc driver. So, yes, okay, if we take this custom driver crate and so it has this main file. It has this main function. Sorry. Stop. And when we run it, it is printing some things that don't match what we want. So for one thing, it's calling itself rustc, which we probably don't want. If we're writing our own tool, we want it to have its own name. We don't want it to be called rustc. So what I'm going to do is I'm going to copy the implementation of this function, just literally. Okay. And I'm going to see if I can change it so that it prints the name that I want it to instead of the name of rustc. I did a thing. Hold on. This is what used to be there. Okay, good. Very good. All right. And This is going to give us a bunch of errors because we don't have imports. I am going to fix that. Cool. Let me see if I can get, yes, Rust Analyzer is giving me suggestions. Excellent. This is great. I can just go line by line and be like, this is great. Perfect, perfect. And you can see here that like 90% of the things that I'm importing are from Rust Driver. Some of them are from other Rust crates, but most of them are from Rust Driver. How many do I have left? I have 8 errors left. That's fine. Cool. No, I don't want to inline this function. Goodness. What else? What else? Wow, there sure are a lot of imports that I need to add, aren't there? All right, cool. I'm adding some more imports. And notice an interesting thing here. So when I ran cargo add signal handler just now, this is a dependency that is in both Rust Driver and in my crate. And I didn't actually have to add it from crates.io. I actually can reuse the version that Rust Driver is using. So if I take this cargo.toml here and I comment out the new dependency that I added, and I change this to load not just Rust Driver, but also signal handler, this will work. You can load the dependencies of Rust Driver yourself, which you would be able to see better if this were working and compiling. Notice also how I'm going to have to add this for every crate that we load from the sysroot. It's not just going to be Rust Driver itself, it's going to be all the dependencies of Rust Driver. We need to tell cargo that all of these are coming from the sysroot. We need to tell Rust that all these are coming from the sysroot and not from a cargo dependency. Cool, this is progress. Oh, I'm surprised that didn't work. I'm very surprised that didn't work. Maybe, what version of Rust am I using? I'm using 1.71 nightly, which is too old a version. Aha! So if I run rust update nightly, this version of Rust did not use signal handler. But if I update to a newer nightly, one that's not a month old, this one will have signal handler in the sysroot because they've added that dependency upstream in the Rust-Lang Rust repository. Cool. Oh, that didn't work still. Oh, that shocks me. Wait, that actually shocks me. Okay, so let me go over and see where it gets signal handler from. So this is in Rust Driver impl. Driver impl / cargo.toml. Where is it getting signal handler from? Okay, it is. Okay, well that explains why I couldn't find it. It's because it's actually a module in Rust Driver. It's not an external dependency. Well, that explains a lot. That's a good thing I ended up not using the version from crates.io because it would have been the wrong one. Okay. Signal handler. Cool. Excuse me. Why does it say that it can't find this? Is it private? I bet you it's private. I bet you that's what's going wrong. Yep, it is private. Okay, well, I guess we just aren't able to do this. I'm annoyed, but that's fine. We don't really need a signal handler. Okay, cool. Why is it giving me errors? So the errors that I'm getting now are related to copying the code into my own process. So this one was about having a private field, which is fine. I don't really care about time passes. It's like a way of measuring performance, which I don't care about right now. And the other thing is it says diagnostic message from string is not satisfied. So Why did rest analyzer get confused again? That's strange. How odd. I'm going to reload the server and see if that helps. Now it works again. Okay, I think when we updated the toolchain, it got confused. It was trying to look in the cached version of the toolchain that it had, which was 1.71, and not the new version of the toolchain I have, which is 1.72. I will open a bug later. Excellent. Okay. Okay. So now. We have REST Analyzer integration again, and I'm trying to figure out why it's giving me this error. It says something about strings and diagnostic message. So this diagnostic message thing is something that comes from REST-C error messages. Okay. Oh, you know what it is? I bet you that when we updated the toolchain, the implementation of REST-C driver main changed. I bet you that's what happened. And so if we look at what it is now in the new version, 1.72 and not 1.71, then, this is no longer a reference to a string, it is now a real string. So I bet you this is going to fix our error. Cool. I am trying to write as little code as I can because I am lazy. All right, cool. And we can see here that we got the same effect as before, except now that we've inlined all of this code. Stop. And I'm gonna fix these warnings here because I don't care about them. Cool. Excellent. All right, cool. And so now I want to change the name from being REST-C to being something else. Actually, before I do that, let me talk about what this code is doing. So we have this init env logger here. So REST-C has a cool thing where it will let you see a bunch of stuff about how it compiles crates when it is running. And you can do this with any version of REST-C. You can even do it with a version that you got from RustUp and did not compile from source. And I'm going to set REST-C log equals debug, and that will print a bunch of things. Let me run touch so that, there we go. There's some output. All right. And I'm going to also, cool. So one thing, there's a lot of logging here. If we count the amount of logging, there are 24,333 lines of logging, and this is not even all the logging. So I'm gonna, so one difference between the version that you compile locally and the version that you compile, that you download from RustUp, is that the version that you download from RustUp does not have debug logging enabled, only has info logging enabled. So just this info logging is 24,000 lines. The debug logging is over 2 gigabytes. I think it was over 20 gigabytes actually last time that I tried it. But you never want to read all of the logging. You want to find the thing that you care about and limit it to that. So for example, if we were interested in the link arguments and we didn't know about the existence of print equals link args, we could actually find that information by setting REST-C log equals cogen SSA backlink, and that will print the arguments for us, and it will only print things from that module. Notice now how there's 90 lines of logging instead of 24,000. So in general, when you are like working or debugging on the compiler, you want to limit it as much as you can, so you only see the things that are important. Okay. And I'm not going to dive into these implementation details too much. All right. Callbacks. Yes. Okay. So. The other thing that this driver process is doing is it installs an ICE hook. ICE is compiler jargon for internal compiler error. You can actually generate an internal compiler error in any program that you like by saying break rust. This is an Easter egg that says hello, yes, I would like to break the compiler. It looks like you're trying to break Rust. Would you like some ICE? The compiler expectedly panicked. This is a feature. I love this. This is actually great. Right, yes, good. Okay, so internal compiler errors are when the compiler panics. And this is a hook that catches those panics and tells people to report a bug because we want to know about these bugs and fix them. This one in particular is a joke, but normally they would go to like here. This one in particular, actually. Okay, yes, good. All right, so we install a bug report. Right now it goes to Rust like Rust. We could customize that if we wanted to. It has some other things. Okay. So this catch with exit code is taking like an internal error type and turning it into an exit code. So that one is not particularly interesting. But this interface result type is also not as interesting as it looks. It is standard result, and then we have this error guaranteed type that says the compiler emitted an error at some point, but like not. It's not interesting. It doesn't do anything. It doesn't have any information. The information is all the errors are all reported eagerly in the compiler, which is both good and bad. It means that it's easy to write new errors, and it also means that it's hard to handle errors. I don't have time to talk about that, but yes. If you want to use the compiler programmatically, it is hard to do that because it will emit user-facing errors as it runs. Okay. It looks at the arguments. It makes sure that they're Unicode, and it calls this run compiler thing. What is run compiler? If we look, it says this is the primary entry point for Rust-C. It takes the arguments, it takes the callbacks, which I'll talk about in a second. It takes the file loader, which is what reads files from disk, and it takes an optional code gen backend. So an interesting thing here, code gen backends, the reason this is optional is because not all things that call the compiler emit objects or executables. For example, Ruststock and Clippy both do not have a code gen backend because they're not creating a executable. They are running lints, they are generating documentation, but they are not actually generating a final binary. So that's why that's optional. And then this callbacks thing. Right, so there's a whole bunch of stuff here. The one that the one, I'm going to use Clippy as an example because Clippy is simple in a way. It has, so the way Clippy works is it takes this after analysis callback. Analysis is like just shorthand for type checks, and it does name resolution. It does all the things that make sure your program is valid. So Clippy makes sure that the program is valid, and then it runs a whole bunch of lints in this callback. Right. I wanted to change the help that it prints. Okay. So if I want to change the help that it prints, what could I do? Stop. Excellent. Okay, so this says Rust-C here, but it has some other things around it. So I'm going to look for this usage string in the Rust repository. So this is hard-coded here, which is not super fun because it means we're gonna have to re-implement this whole function if we want to. But we could like copy this whole function and put it in our program and just like change REST-C to custom driver. I'm not gonna do that because I don't feel like doing it right now. But we could. And actually for that to work, we would have to actually copy all the other things around it. So like this call site here, hard code usage, so like everything here we'd have to copy to. It would be annoying. But we could. Ruststock does something similar. Excuse me. Yeah, something like that. Yeah. Where it copies the things that it cares about and not the other things. Like it is possible to do. Yes, good. Okay. All right. So now we have a compiler. We can do cool things with it. I'm going to steal one of the people who works on the compiler. Is called Tom Civiolani. He has a Twitter. Where's Tom's Twitter? Here we go. He has a Twitter, and one of the things that he wrote was a custom driver that just completely deletes the borrow checker, which is so much fun. Hold on. Here we go. This is the one. You're welcome, and I'm sorry. So this is one example of cool things you can do with the compiler. I'm going to ignore this boilerplate for now, but the thing that actually does things. Okay. So this says when you borrow check a function or type, run this function, which is called not a borrow checker, which says there are no errors. No matter what the function is, there are no errors. And so if we if we were to compile this custom driver and to put it in path somewhere and run it, then it would say that any program we compile has no borrow check errors. I'm going to do that, actually. I'm going to do that right now. Let's have fun with that. Cool. Right. Okay, and so, okay. The reason this is giving us errors is it's based on an old version of the compiler. So because we are loading this from the sysroot, whatever version that we load from the sysroot is going to have the API that of whenever the toolchain is published. And so whenever you update your toolchain, there is a chance that there will be breaking changes that just completely break your program. I'm going to see if I can make this compile in the simplest way possible. What has changed here? So extern providers. Okay, so I'm going to go back to the documentation site from last time, which is the list of cargo generated, of reststock generated things in the crates. And I have found extern providers, and I'm going to replace that here. Okay, so apparently the tie prefix disappeared is the change that happened. Cool. Very good. Okay, so I'm going to combine this with the work we did last time, and I am going to put this in path. Specifically, so the thing I did last time, somewhere in here, yes, I wrote this little thing here that runs, okay, so it runs the version of itself for the given toolchain. So the idea here is that we're going to call it as cargo nightly custom driver. No, sorry, cargo nightly build, and that will call the custom driver like that. Let me go do this in the sample project. Cool. So this is where we were last time, where I had infinite recursion. And what I'm going to do is I'm going to rename this proxy to unbehavior rest C, because I love that name. That is a fantastic name, my God. And the second thing that I'm going to do is I'm going to take this driver that it's built, this program called ub-rest-c, and I'm going to copy it over into rest-c print sysroot /bin. And what this is going to do is when we run this on our example program over here, is it is going to let us say, it will let us use this custom driver. Why is this still not working? Did I have a bug in this script? That does seem very possible. That does seem like something I would do. Let me open this file up. Why did that? Because I moved the file. That's a good reason. That's a good reason. Cool. Aha. Okay. So what I thought rust up would do Oh, that is fascinating. It does work when I run it outside the script, but it does not work when I run it inside the script. Why could that be? I'm going to print what it's doing so that I can tell what's going on here. Okay, so it is calling itself over and over, but why is it doing that? This is the full path of the file. We don't want it to be the full path of the file. We want it to just be the base name of the file, because otherwise this rust up run is not doing anything. It's just calling itself over and over. Why did that not work? I forgot to put a $sign. Don't you love shell scripts? Okay, cool. And so now we can see that it managed to run this new custom driver that we built. This one here, right? And it broke the compiler. And so now what I'm going to do is I'm going to use that to create a program that will build with our custom driver, but that will not build with normal rust-c. So a simple example of a program that won't build with rust-c is I'm going to say this function needs to return, it's going to take an arbitrary string with an arbitrary lifetime, and it's going to return a static string that lives for the duration of the program. And normally, when you build this with normal cargo, this is going to give us an error. Lifetime may not live long enough. This is like a common error you'll see when you're developing Rust for the first time, because you're like, okay, I have to like get used to the spar checker that thing's and is a thing. But what if it weren't a thing? Look at that. Okay, so now we can actually run this program, which allows us to use strings after they've been freed. I don't know whether this will break or not. This is what's called undefined behavior, which means that there is no guarantee for what the compiler will do. Maybe it will work and maybe it won't. In this case, it happened to work, and I think that's because the string lives until the end of the statement, because it's a temporary. I'm going to see what happens if we move it so that it's free before we print it. Oh, look at that. Okay, yeah. So now we have taken this program, we have run it, we have used it with a string that was already freed, and now we get random garbage. So this is why Rust has a borrow checker, so you don't get random garbage. And this is not the worst thing that could happen. You can also get like seg faults and security issues and all these other things. Anyway, right, cool. So we have this custom driver working. I don't know what I was going to do next. I was writing a blog post. I forgot I was writing a blog post. Okay. Right. So I was going to copy some things in that are interesting. Probably not all these things because some of them are not helpful. Cool. That was this code, which I'm going to copy into, and I think the rest of this video is actually going to be pretty boring because I'm just copying code over. Okay, this was fun. Thank you for listening in. Hopefully it was interesting. I did not look at the Twitch chat at all, so if you said something there, I am very sorry. Goodbye.